Hello everyone. Now here when you want to calculate standard enthalpy change of the reaction at standard state, that is standard enthalpy of the reaction, use this equation: standard enthalpy change of reactant minus standard enthalpy change of the product. So this equation should be used to solve the problems if bond enthalpies are given. Now exactly opposite thing we'll have to do when you want to find out standard enthalpy change in the reaction when only the standard enthalpies of formation are given. So in this equation you will have to subtract enthalpy of formation of the product minus enthalpy of formation of the reactant here. Okay, so here reactant minus product, and in this case you will have to go for product minus reactant. This is the case when you are given the bond enthalpies, and this is the case only when the standard enthalpies of formation are given. So carefully you will have to apply the equations whatever the type of problem which is given, taking into account the given data. You will have to choose the equation based on that. Now the next concept, that is the spontaneity of a chemical reaction. Now if you are reacting two reactants together, the question arises whether they will react or not. So the first question you can come across that if there will be reaction or not, means if molecules or the molecules react or not. This is the first thing. Secondly, you can say if they react together, at what speed? What will be the speed of the reaction, that is the rate of the reaction. Third, whether the whole amount will be converted into product or not, means what will be the percentage yield of the reaction. So these three questions might arise when you talk about any chemical reaction. So the answer of this first question, it is given by thermodynamics, whether the molecules will react together or not. So the reaction which occurs in its own, that is called as the spontaneous process. So since we are talking about the spontaneity of the reaction, so if the reaction is occurring on its own, that is called as a spontaneous process. Okay, so spontaneous processes are those which occurs on their own. For example, when you perform any acid-base titration, this performance of acid-base titration, when you perform this reaction in the chemistry lab, you are adding base from the burette and to the acid, and they start reacting together to get the formation of salt and water. This is very commonly used titration in the chemistry lab. So you don't have to supply energy. In some cases you might have to supply energy, like in redox titration, but for acid-base titration you need not have to supply energy. So it occurs, this reaction occurs without any external influence. So whenever any reaction is carried out, there is always change in its energy. There is always change in the energy. So if any reaction, whether it will occur or not, so this energy is very much important here. Okay, so water flows from high altitude to low altitude. It never flows in reverse direction. It means if a system is at higher energy, it has higher energy, it will always try to be at lower energy. So it will try to be reach at lower energy level. What is the purpose of doing this? Only thing is as to attain stability. So this thing is done just to attain the stability, okay, or to become the stable. So all 118 elements try to be stable when the reaction occurs. So all compounds and molecules, they always try to be stable, to reach the stable state. Now if any reactant, it is converted into product, the product obtained on completion of the reaction would be more stable than the reactant. Then only the reaction, whatever the product you are achieving, that will satisfy your requirement. Otherwise, if the product is firm and if it is not stable at room temperature, it's of no use. So the thing is that whenever the reactant is at higher energy level, it should reach to its lower energy level to attain the stability. So this occurs in nature also. So the reaction is spontaneous when it starts at higher energy and reaching at low energy level. So energy is released in the form of heat and given to the surrounding here. So every exothermic reaction will be a spontaneous one. So you can conclude here, every exothermic reaction is all naturally occurring reaction. If some of them are exothermic, then they would tend to be spontaneous one. Now, what about the endothermic reaction? Are they not a spontaneous one? So, for example, melting of ice, it is converted into water. This is again a spontaneous process. You are not supplying any energy, nothing, but still it is converted into water when it is kept at room temperature, and this is an endothermic process. Means when you say that all the reactions should start from higher energy, they should reach at lower energy to attain the stability. Means most of the exothermic reaction, you can conclude that those are termed to be a spontaneous one, like the acid base titration here, where there is a evolution of it. But this is the another example that conversion of ice or fusion of ice converted into water, it is a spontaneous one, but it is an endothermic reaction where there is heat is absorbed. So you can't say that when the reaction is found to be spontaneous, it need not have to be an exothermic one, it can be endothermic also. So energy is not the only criteria. When I say this should reach from higher energy to lower energy, but here exactly opposite is happening. Fusion of ice, it is the absorption of heat energy, which initially it was at low energy, and after some time when it is converted into water, it will be now at higher energy. But still it is a spontaneous and it is an endothermic process. So energy is not the only criteria. This is not the only criteria to decide whether the reaction would be spontaneous or not, to decide the spontaneity of the reaction. So there must be some other factors which decide the spontaneity of the reaction, and what are they we will study further. Thank you.